Hello everyone and welcome to my lecture on resonance part 6, where we are going to discuss about how resonance governs acidity and stability of isomers, taking example of ortho-nitrophenol, meta-nitrophenol and para-nitrophenol. Before going into it, let's have a look at the acidity of phenol. Phenols are stronger acids than alcohol but weaker acid than carboxylic acids. Let's have a look at the data. Methanoic acid has a pK value of 3.77. Phenol has a pK value of 9.95. Methanol has a pK value 16. Lesser the pK value, more is the acidity. So, methanol is the least acidic. So, why are alcohols the least acidic? In alcohol, though the hydrogen is attached to a electronegative oxygen, it cannot be easily removed because of the plus I inductive effect of the R group. Moreover, the alkoxide ion, if formed after the removal of the proton, cannot be stabilized because of the plus I inductive effect of the R group. Therefore, alcohols are very weak acids. Its hydrogen atom can be removed only on the treatment with metals like sodium. Let's have a look at phenol now. Phenols are weak acids. In phenol, the hydrogen is attached to electronegative oxygen, and so it has a minus I inductive effect. Moreover, the lone pair electrons on the oxygen can enter into resonance with the pi electrons of benzene ring, and so it has a minus R effect also. Therefore, the OH hydrogen is slightly acidic. These are the resonance structures when the lone pair electrons enter into resonance with the pi electrons of benzene ring. As this delocalization of lone pair electron happens, then there is a charge separation, and therefore the resonance structures of phenol are less stable. After removal of the proton, the phenoxide ion is formed, in which the negative charge on oxygen enters into resonance with the pi electrons of benzene ring. As this delocalization happens, there is no charge separation, and so the resonance structures of phenoxide ion are more stable than the resonance structures of phenol. The stability of the phenoxide ion over phenol make phenol more acidic. The proton of the phenol can be removed by strong bases like NaOH. But why are carboxylic acid more stronger acid than phenol? In carboxylic acid, the hydrogen is attached to electronegative oxygen, which is in turn attached to an electron withdrawing carbonyl group. So it has a strong minus I inductive effect. Moreover, the lone pair electrons on oxygen can enter into resonance with the carbonyl group. So it also has a minus R resonance effect. Therefore, the OH group is acidic because of minus R and minus I effect. Now, this is the resonance structure of carboxylic acid. And in this resonance structure, when the lone pair electron enters into resonance with the carbonyl group, there is a charge separation, and therefore these resonance structures are less stable. But after the removal of the proton, the carboxylate ion that is formed, in which the negative charge on the oxygen enters into resonance with the carbonyl group, there is no charge separation, and not only that, in both the resonance structures, the negative charge is delocalized between the two electronegative oxygen atoms. Therefore, both structures have equal energy and more stability. Therefore, the proton, the stability of the carboxylate ion makes carboxylic acid a strong acid, and the proton of carboxylic acid can be removed even by a weak base like sodium bicarbonate. The next question is, how can you increase the acidity of phenol? We can increase the acidity of phenol by introduction of an electron withdrawing group. Why? The answer is resonance. When nitro group is introduced at the para position with respect to OH group, we get para-Nitrophenol. And when nitro group is introduced at ortho position with respect to the OH group, we get ortho-nitrophenol. These are the resonance structures possible for para-Nitrophenol and ortho-nitrophenol. It is observed that the acidity of ortho-nitrophenol and para-Nitrophenol is more because of minus I and minus R effect of the nitro group. The lone pair electrons on the oxygen of the OH group not only enters into resonance with the pi electrons of the benzene ring, but also with the nitro group. More the resonance structure, more is the stability, and therefore para-Nitrophenol and ortho-nitrophenol are more stable and more acidic than phenol. Look at the data. The pK value of phenol is 9.95. pK value of para-Nitrophenol is 7.07. Ortho-nitrophenol is 7.23. The data shows that para-Nitrophenol and ortho-nitrophenol are more acidic than phenol. And it also shows that para-Nitrophenol is more acidic than ortho-nitrophenol. Why is it so? The explanation for this is that in ortho-nitrophenol, the nitro and the OH group are in close proximity with each other, and they form a hydrogen bond through the formation of six-membered ring. Therefore, the proton in ortho-nitrophenol cannot be eliminated easily. But in para-Nitrophenol, the nitro and the OH group are far from each other, and therefore there is no question of formation of hydrogen bond. Therefore, the proton can be easily eliminated in para-Nitrophenol, and hence it acts as a stronger acid than ortho-nitrophenol. The pK value for para-Nitrophenol is 7.07 and pK value for ortho-nitrophenol is 7.23. Again remember, more the pK value, lesser is the acidity of the compound. Now coming to the last part of our discussion, we have discussed that para-Nitrophenol and ortho-nitrophenol are more acidic and more stable than phenol. But what about the other isomer, meta-nitrophenol? It is observed that meta-nitrophenol is less stable and less acidic than the other two isomers. Why is it so? The answer is again resonance. These are the resonance structures for meta-nitrophenol. In none of the resonance structures, the nitro group, the lone pair electrons, can enter into resonance with the nitro group. Therefore, the number of canonical structures are less. Meta-nitrophenol has 5 resonance structures, which is similar to that of phenol, and para-nitrophenol and ortho-nitrophenol have 6 resonance structures. Lesser the number of canonical structures, less is the stability. Therefore, meta-nitrophenol is less stable than para-nitrophenol and ortho-nitrophenol. Moreover, since the nitro group cannot enter into resonance, therefore, the acidity of meta-nitrophenol is close to phenol. pK value of phenol is 9.95 and pK value of meta-nitrophenol is 9.3. Meta-nitrophenol is slightly more acidic than phenol because of the -I effect of the nitro group. And that's all for today's lecture. If you like my video, please subscribe, like, share and comment. Before I end, I want to end with a thought. Each fresh peak ascended teaches something. Thank you and bye-bye.